I want us to graph y equals to negative 2/3 x minus 1. Notice this line is in the form of y equals mx plus b. Your y-intercept is negative 1. So the first thing I'll do is I will go down on the y-axis to negative 1 and make a point. Your slope is negative 2/3. I always keep the negative with the numerator, and therefore the denominator is positive, because the only way that you get a negative number when you divide is if one number's negative and the other number's positive. So here I'm letting my negative stay in the numerator. That will be my rise. I will rise downward. Your run is positive. So if your slope is a fraction, one number must be negative, either the numerator or the denominator, and the other one must be positive. So from this point, I will rise negative 2. Rising negative says go down 2. So from my point, I will rise negative 2. 1, 2. Then I will run positive 3. So let's run 3. 1, 2, 3, and make a point. You don't make a point until you rise and run. Let's do that again. We can rise negative 2 again. Rise negative 2. 1, 2, and run 3. 1, 2, 3, and make a point. So you see, there's my line. It is slanting downward to the right. It does have a negative slope, like every negative slope line is supposed to. Now, I also want to talk to you about if I had the slope positive 2 over negative 3, this is the same thing. You can change each one of these to their opposite and find the upper part of the line. If this slope, negative 2/3, gave you the bottom part of the line, you can change each one to their opposite, change negative 2 to positive 2, change positive 3 to negative 3, and you still have the same fraction, negative 2/3. It's just this time the positive goes with the numerator and the negative goes with the denominator. So I'm just wanting to show you that if I use, this is my slope, positive 2 over negative 3, I'm simply just finding more points on the same line. So I'm going to go back to my y-intercept, and I'm going to rise positive 2. Well, if you rise positive 2, here you are. And if you run negative 3, 1, 2, 3, there's another point on the graph. Now, my line was not as straight as I wanted it to be previously, so I'm going to straighten that out for us. Okay? So you see that the line passes through that point. Okay? So if I rise 2, go to the left 1, 2, 3, this point is still on the same line. And I could do that again. I could rise 2 again and run 3. And you see, it's out here as well. I could just keep going. Okay? I could just keep going. And you could see that every time if you rise 2 and run negative 3, negative 3 says go to the left 3. You will find the point here. If you do it again, you can rise positive 2, run negative 3, running to the left, negative 3. And we could keep going. So whether you use negative 2 over positive 3 or positive 2 over negative 3, that's the same thing. Now, that would be just like if I had a problem y equals 2, 4/5 x minus 1. I could use positive 4 over 5 as my rise over run. And then I could change both of these to the opposite and use negative 4 over negative 5. And I would still find more points on the same line. So let's look at this graph. So if I was to plot my y-intercept of this problem at -1, I would go down to -1. Your rise is 4, your run is 5. So if I rise 4 positive and run 5 positive 5, let's see what we would get. Rising 4, 1, 2, 3, 4, and running 5, 1, 2, 3, 4, 5. There's a point on the line. Now, if I use this slope from my y-intercept, this says rise -4. So I'm coming down 4. 1, 2, 3, 4. And I'm running -5. To run -5, I need to go to the left. So go to the left 5. 1, 2, 3, 4, 5. There's another point. So you see that my points do line up. They do line up. So this point I found by rising +4 and running +5 to get to this point. This point I found by rising -4, going down -4, and running -5. So whether you have both of them +4 or change both of them to their opposite, -4 over -5, you see I just found 2 points on the same line, passing through the y-intercept at -1.